Several people have asked about the development environment I use when coding Sam stuff. So, as promised, this is a quick tutorial to show my basic setup and also to do the first part of sort of the game ROM system I create when I'm doing any Sam assembly work. As with most stuff, it's not the only way. It's the way I do it. You may like it, you may not. I'm sure there are lots of people that will tell you there are lots of better ways to do things. I'm always prepared to listen to other suggestions, so if anyone wants to comment and say things that they think would be better, then by all means drop me a message. There's nothing clever about the way I set this up. I use Visual Studio all the time for my day job, so I tend to use that as I'm familiar with it. It's just running batch files, so all I'm going to do is create a new project. It's just a makefile project. In this instance, we'll call this one basic setup, because this is the first tutorial. As I say, it just runs batch files. So when we run the build command, it's literally going to run a batch file we'll create called build.bat. When it cleans, we'll do clean.bat, and rebuild, surprisingly, rebuild.bat. The output file, I create a disk file. So again, main.disk. We could start using preprocessors, etc., and pass them in, but to be honest, I don't tend to bother. Release settings are exactly the same, as again, I'm not passing in debug, non-debug, preprocessor define. You may want to. It's entirely personal choice. But that's all I use. So I create this project. There's nothing really here. I'm just going to do a bit of tidying up, because I don't really want that. This will be include files, and I will add one more folder for data files. One of the data files I will actually create first. We'll create a new item. Just a basic text file, and we're going to create this and call it build.bat. This is the batch file which actually compiles the project I'm working on. I use a assembler called PYZ80. There are others around, and it'd be very simple to adjust this script to use whichever editor you want, whichever assembler you want to use. PYZ80 is a Python-based assembler, so I've already got Python installed on my C drive under Python, and then I get it to run the assembler, which is sitting in the Sam Coupe tools directory called PYZ80. So that's the actual assembler. Now to pass in, the few command lines I use. The first one is -I samdos2. Excuse me, I want to be able to boot the disk, so we need to have samdos on there. This includes that as the first item on the disk, so we're able to boot. -O is the output file. So in this case, main.dsk, as we put in the project settings. There's a couple of other options I use. One is no zip, and one is case. You can use these as you want. I like to have it with the case sensitivity set like that. And for some reason I don't tend to zip the disk image. Again, it's something personal choice, doesn't really make much difference. Map file. Now this, if you're using Sam Coupe to do any testing, map file is a very useful little function. It will generate a text file which holds all the addresses of various variables for your project. If using Sam Coupe version 1.1 alpha, if you ever use the debugger inside it, it will actually load up this map file. Basically, it's called the same as your disk image, but .map run .dsk, and it will actually show you the names of the functions and variables, which just makes debugging on Sam Coupe a little bit easier. Doesn't slow the game or anything down. So, and finally, we just need the assembler file we're going to build. In this case, I will start with main.asm. So that's our save that. That's our build batch file. We also had a clean batch file. This simply does a delete of the disk file, and then finally we had the rebuild. Rebuild effectively just cleans out any data files, object files, and makes it sure that it completely rebuilds the entire project. In Z80 stuff, there's not really much to it. You can add, occasionally I've had some stuff where I've had custom build steps to generate graphics and data, but for now, literally all we're going to do is the rebuild will call the clean, and then it will call build.bat. So we're just using the other two files. Clean, get rid of the disk file, and rebuild it. Those are the three batch files that do most of the work, and you could set them up in Notepad++ or anything else to do similar things from whatever editor you want to use. Now, the next only other thing we now need to create is obviously our main.assembler. So I'm a bit anal when it comes to writing code. I like it to look neat. I find it makes life much easier when you come back to projects and when you want to reuse code. So you'll see I'll quite often split code up and I'll put headers on it. In this case, it's just so I know what this one is. This is the basic setup tutorial. The next thing I need to do is I need to use the org command. I'm assuming most of you know the basics of assembler. This tells it we want to put this, compile this code as though it's going to be running at memory address 8000 or 32768 decimal. But it's the start of memory page C. It's quite a convenient place to start doing bits. And use the dump command to dump it into page 1, offset 0. On the Sam Coupe you've got lots and lots of pages, so you can use the dump command to say whereabouts in memory, actual memory it's going to sit. Obviously you have to be aware that where you're going to page it into to make sure you use the org command to compile it as ready for running in that particular memory page. The other thing I want to use is autoexec, which tells PYZ80 I want this to run. When it generates the disk image, it will put in the basic loader and set it so this loads. So now we've got that, we can start writing a little bit of code together. So this effectively the same setup I use no matter what project I'm doing. I'll quite often copy the program from one project to another. On the start, disable interrupts, just stop things happening for a little while. I always like to have a way of getting back to basic. It just makes things a bit quicker. So I always need to, as I'm going to do a lot of bits and pieces with stacks, moving stacks around, pages around, the first thing I'm going to do is store the stack pointer. The +1 will become apparent in a moment. We can now go and put it in so we can see. System restore, this is what would be called when I want to go back to basic. Again, disable interrupts. As I've more than likely moved the stack pointer, obviously it needs to be back where it was when we started. So basic, the Sam Coupe basic doesn't get upset. I could store it in a variable. Up here I could write this into a SP store variable, but save memory and a bit of speed. +1 means it writes into this memory address, but adds 1 on for the LDSP instruction, and we'll write the value straight in here. So when we come in here, it'll have modified this piece of code, so the LDSP is the right address for the stack pointer to return. And we're going to have a very similar for the lower memory page register. So what we want to do there is load A with whatever the lower memory page is. I've got a fairly good idea what it will be. I could hard code it, but just for safety, write it out to the LMPR. So that's going to put the lower memory page back again, enable interrupts, and return out. That's all there is to the system restore. And then if I go back up, we just need to finish this, and this will be, remember the current stack pointer. You never have too many comments, well, occasionally. And now we're going to grab the current LMPR install data. And this is simply in getting the low memory page register address, store it into the LMPR restore memory +1 because we want to skip over the LDA instruction in this case. Now we're going to page in our game ROM. I tend to put my game code into the ROM address, memory address starting at 0. There's various reasons I do this. A lot of people will tell you there are better ways of doing it, different ways of doing it. There are lots and lots of different ways of doing it. I happen to like this way. Each to their own. If you think there's a reason not to do this, by all means drop me a message. As above with the dump command, you saw we put this into page 1. My game ROM is going to go into start page 2. And I have to add in the 20 hex to say I'm going to page out the actual ROM. Otherwise the actual ROM would still be there. So we out that to 250, which is LMPR again. The advantage using game ROM, I find, is you can actually use the RST vectors for common functions. So in this case, to start the game completely from fresh, like if you were using what to restart the SAM in assembly, you could call RST0 on the SAM ROM. I use RST0 for the start of mine. So we're just going to start the game ROM up. Simply RST00. That's all there is to the actual main initial part, but obviously now what we need to do is to write the game ROM that's going to page in. You could put this all in one long file, but as I said, I'm a bit anal about how the code looks. So I tend to split my project up into multiple include files. Include just says bring in another assembler file, so we don't have to build all the assembler files separately from the command line. We just build main and it includes all the rest. In this case, I'm going to call this game.rom.asm. Also means it makes it easier when you want to copy these things from project to project. So if I now create another new item, call this game ROM. Again, I'm going to want a very similar setup. Just copy it. This is going to be running from memory 0, as we saw start page 2. We don't need the auto exec for this. Now, what I tend to do to start with is to set up the basics. So RST00 vector. With the RST vector, because I'm not going to fill all these in with any code now, you've only got 8 bytes between each of the RST vectors, and you want to make sure that you're not going past that. Otherwise, it'll cause all sorts of problems as you're running code. So there's, with PYZ80, there's a little command called assert, which makes sure that, in this case, it ensures something is true. So we want to say the RST00 vector is actually equal to 0. If the RST00 vector isn't equal to 0, we've got a bit of a problem. And now all I'm going to do is jump to initialize. So at any point throughout the game, no matter what, I can do RST00 and it starts the game off as though the game is completely fresh and nothing's changed. Obviously I know that's only 3 bytes. I could just put db and 5 zeros, just in case I decide to add anything else in there. You can use a defined space, and we know we want to define 8 minus the current memory location. So in this case it'd be 3, so it'd actually put 5 spaces in. Saves me, if I write the code, having to work out how many bytes it is before the next one and keep changing the DBs, it's prone to error. So use DS, just makes life a bit easier if you go and change it later. I'll quickly do the rest of these, which are all going to be very similar. Obviously the RST08 vector needs to be at 8. I'm not going to actually have any code in here, so we just want to find a space between 10. And we need to do this for 10, 18, 20, 28, 30, and 38. So now we'll just go and quickly fill these in. So that's the 10, goes to 18, 18, goes on to 20, 20, goes on to 28, 28 goes on to 30. Now RST38 is a slightly different beast. It's effective same, but as hopefully some of you know, there's 2 interrupt modes on the Z80. IM1, IM2, well it's actually 3, IM0, IM1, IM2. Main ones we tend to worry about IM1, IM2. IM2 needs a jump table, IM1 will automatically jump to RST38. So sticking your code into the game ROM means you can just use interrupt mode 1, you don't have to set up any tables, it's just nice and convenient. So, but it does have to say it, 38, so we'll just add in this against the cert check. Ooh, copied one too many down there. For now, we're not going to do anything in the interrupt routine, so we just need to enable the interrupts and return. You can use ret or ret-i. Ret-i is probably technically correct because it can be monitored by external hardware, which why you have got an RETI. Ret would actually work. I think the Sam ROM just uses ret anyway. So that's our interrupt routines. The next part is only if you want to. You don't have to. There's one more handler, which some of you may or may not be aware, at memory address 66, and this is the NMI, the non-maskable interrupt handler. If you press the little break button on the back of the SAM, this is where it goes to. It calls into memory address 66. You may or may not have seen some games and projects have it so when you press the break button you get a screen flash up before it restarts, or what have you. That's how they do it. They hook into here. All I'm going to do for now is I'm going to simply do an RST0. So if I want to press the break button, it just restarts the game. So having done that, we can now get onto our initialize function. This is obviously where we jump to. Remember back up at RST vector 0, we just jump to initialize. First thing I'm going to be doing in my code is setting up my own stack, because we've paged out the basic stack that was there, so at least we have our own stack, we know what's going on. I'm going to remember what's in the higher memory page register, so I can do a shutdown so we can get back to basic again, like we did with lower memory page register. I'm going to do the same trick, loading it direct into a variable and enable the interrupts. So let's put some comments in. So this is set up our game stack, and this is remember the HMPR for restoring, for shutting down of the game ROM. All I'm going to do for now is this is just showing the base setup. I'm not going to do any actual game stuff here at the moment. I'll leave that for the next tutorial, and I'll probably do some double buffering and sprites and what have you. What I'm going to do here is just jump to shutdown. shutdown is literally the code that will bring the game back to basic. I'd probably take this out if and when I release software. There's no harm in leaving it in. First thing we'd have to do is restore our HMPR, which where our original software is sitting on the startup bit that we've done in main.assembler. So again, we just want to get the A, which is set up in the initialize function. Set it up, and then we can jump back to our sysrestore function that we wrote in the main.asm. The last little bit is obviously we just need to set up a stack. As you know, stacks work backwards, so I'm going to have a 256 point stack. Obviously we have to set a stack at the end of it, as we push things on it will work its way back up through memory. And that should be all we need. Fingers crossed it runs first time. Because I'm using Visual Studio and I've set up these batch files, I just press F7, whichever key got set up for it, to build it. Ooh, I've always got a few errors. The one thing I've forgotten to do is I've forgotten to, if you remember in the build.bat we asked it to include SamDOS. What this error is complaining about is it doesn't know where SamDOS is. Because we haven't created the data folder, we'll put SamDOS in there. So I'll just go and find a copy of that. I've got one in Treasure Island Dizzy. So if I go and open up that folder, here's SamDOS. That's number one. Undefined, I've probably named it wrong. So we check. Initialize. That's be better. Oop. And then this one of these certs, that should have been RSD30, should be at memory address 30. That's why the certs can be quite handy sometimes. Helps a bit debug. And then we have it. It's compiled the code. Now to run it, what I tend to do is in here I can go and set up the command for what it's going to run. In this case it's my Sam Coupe, which is installed on my C drive. Then the arguments I need are, I want to tell it I want to load disk 1 with our little ROM we just built. So in project dir, so that's where it gives it the path. This macro that Visual Studio will expand for me to the path of this project, so I can move around. Call it main.dsk, and we'll simply say auto boot yes, so it'll run it. That's all that. So now if I press F5 to run it, and as we expect, we just get the OK message. I can boot the disk again. dir, there's our. It just comes back. We know it's actually running our code. If I go back to our game ROM, somebody may not believe me. It's actually coming through here, initializing, going through, and then just coming straight back out, calling system restore, restoring it. Just to show it is actually running this, what I'll do is I'll quickly load B with 150, and I'll just do a simple halt command, which just waits for 1 frame, and then I'll wait for 150 frames, 3 seconds. Now if I rebuild the project and run it, as you can see there, it's waiting about 3 seconds before it then returns to basic. So that's all there is to my basic development setup, initial game ROM. What I'll do is I'll try and do some more tutorials in a little while, work permitting. we'll try and do one with some graphics. I know there's been some questions on compiler sprites things, so maybe I'll quickly show you a C program, or I'll quickly write a C# program to grab some sprites, create a compiled sprite, and then we'll add something in here to draw a compiled sprite. Hope that's been of use, been of interest. Any questions, any comments, by all means drop me a message. If you think it's completely wrong, drop me a message. I'm not saying that that's the only way or the best way, or it's just simply the way I do it. By all means, let me know any other way that you like.